I'm Oliver. I'm head of engineering at Monzo. I don't know how many of you know Monzo. We have these prepaid debit cards like this, the fantastic pink ones. If you don't have one, you should definitely get one from me or Simon or Matt, who are here tonight. Simon's there and Matt's there as well. What we're doing is we're building the best bank in the world. That's what we're trying to do, at least. And what that means is kind of a beautiful feed with stuff that actually makes sense, rather than kind of cramped 40-character statement descriptors that mean absolutely nothing. We try and show you the real merchant name, like revolutionary things like that. A real-time balance, and try to make it something you can actually understand. When you go into a transaction, you can see lots of stuff about it, like in this case, this was a meal I bought while I was in Seattle, and you can see how much it was in dollars, how much it was in pounds. It's categorized as eating out, like all of this stuff that to us seems quite obvious that you would do, but somehow hasn't happened in banking until now. You also get a notification immediately as soon as you spend with an emoji, which is one of my favorite features, actually. But as I said, we're building a full bank, not just a prepaid card. The prepaid card is something we've sort of built because we want to get a product that people like without waiting 2 years to do it. We've been building this bank for nearly 2 years now. And we are sort of at the stage, at the end of a very long process, where we will have an unrestricted banking license and be able to offer a full current account. Like I said, we've been at it for nearly 2 years. We're hoping to be able to offer a current account in the next few months. And we had a really big milestone toward that this week that sadly I can't talk about, but it's coming very soon. But one of the things that we've had to think quite a bit about in this whole journey over the last sort of 8 months to connect to lots of payment schemes like MasterCard and faster payments and stuff is how to secure our network. And our network is quite a complicated thing because of the way we've sort of designed our systems. And I'll go into some aspects of this. The first one I wanted to talk about is kind of how we, fair warning, a lot of what I'm about to talk about tonight is not finished. So it's stuff we're in the process of building, and it's just kind of how we're thinking about things, and I just wanted to sort of share it and, hopefully open it up for lots of interesting questions that we haven't thought about. And the first one I wanted to talk about was network isolation, which is kind of, we want to separate things on our network so that only things that should be able to talk to each other can talk to each other. And a common approach for doing this is to separate, the gray has been totally lost on there, but is to separate things into layers in your network. So you might have a data layer where your database lives. You might have a DMZ where internet connections come in. You might have an admin layer where your admins can VPN into. But what we do is rerun all of our applications in Kubernetes, and you find that over time, there are very strong reasons to move basically everything into your cluster manager, and you kind of want to do. We haven't yet finished migrating everything in there. We don't have our Cassandra databases in there, for instance, but we'd like to in time. And you find when you do, basically you just end up with one big layer, like from the perspective of the network, which is your Kubernetes workers, which is where all of your applications run. And in our backend, we, as well as running all this in Kubernetes, build everything as microservices. I think we have nearly 200 microservices at the moment, and then a bunch of other things that sit behind them, like Cassandra, like etcd, like all, lots of shared services they use. And there's a hell of a lot of communication going on between these services. A single request received at the API might fan out into tens or maybe even hundreds of calls behind the scenes. And it's quite complicated to sort of reason about what's going on. And like separating this into layers is basically impossible, to be honest. What you really want is a way to say explicitly that I want a service to be able to receive requests from another service. And I don't think we do this for everything. We want to do this for certain services. Like, for instance, we might have a group of services that are about MasterCard, and we want them to be only able to talk amongst themselves. Nothing else should be able to dial into the MasterCard network and say, hey, authorize this transaction. And Kubernetes makes this a bit harder even than that, because every pod gets an IP address, its own IP address. So each machine might have, tens of pods on it, and each of those pods has an IP address. But those IPs are allocated from a pool, so an IP address doesn't really mean anything. It just means it's a pod. You can't really reason much more about it beyond that statically. So what you need is kind of a way to dynamically create rules. And the way we're thinking about doing this is using Calico along with something that was in Kubernetes 1.4 called network policies. And Calico is two things. It's an overlay network, and it's also a network policy engine. We're not using it as an overlay network. We're using Flannel as the overlay network, but we are using it to kind of enforce network policies. Kubernetes gives you this thing which is like you can define network policies, but it doesn't do anything with them by default. It can't apply them. It has no mechanism to do that. But these are quite cool. They allow you to specify on like a pod-by-pod basis what can talk to it. So in this example, I have a service called the MasterCard proxy service, which is saying that I will only allow traffic to come from the MasterCard processor service. And this is in production. It's saying only a service that's in production should be able to do this. This works quite well. It is kind of cluster aware in the sense that it manages these dynamic IP addresses. It talks to the cluster manager to figure out what is at these IP addresses, and it implements basically IP tables rules at the end of the day. It's also quite cool in that it provides filtering at both ends of the connection. So like both the originator of a connection and the recipient of a connection do filtering on it. But it isn't great in that it doesn't control egress at all. It only controls ingress into a pod. So it will allow anything to make a connection out to the internet, for instance. It has no control over that. It also only understands TCP and UDP, but in our case, we want to do things that are kind of outside of that. We want to be able to, for instance, say, these things are the only things that can initiate an IPsec connection to this other thing because we have IPsec between our data centers. And also, it's not that great because we have proxies in between all of our RPC. The majority of our RPC goes through a thing called Linkerd, and there's a Linkerd on every host where all you can see then is the traffic is coming from that host. You have to trust then that Linkerd is receiving it from where you expect it to be. So there's kind of a few things we're doing to overcome this. Calico actually does express egress, and it does express things other than TCP and UDP. It's just Kubernetes doesn't expose that through its network policy. So what we're doing there is kind of adding a layer where it will be able to just take a raw Calico policy in a third-party resource and apply that at the node level. And in the future, I think it would be quite good if we could extend the network policy in Kubernetes to be more expressive and do more things like this. And also building a plugin for Linkerd so it can understand network policies and apply those itself. And this is kind of good practice, but I don't think it's not everything we want from this. And I think the second part of what we need in our network is a strong notion of authentication between services, which is to say that like a service can mutually authenticate with the service it's talking to and with a high degree of confidence say, yes, this is what I expect it to be on the other end of this connection, other than just it's something at this IP. And what we kind of want there is end-to-end authentication. As I said, the majority of traffic is indirect. It goes through Linkerd, and we don't necessarily want to trust that. It sits on every host, and while of course, it's a great piece of infrastructure, all of our traffic goes through it just about, but we don't necessarily want to trust it in really security-sensitive applications. So we want something end-to-end, and what we're thinking about for this is basically providing a certificate to every service. So something that integrates with Kubernetes and provides an identity to every service in the form of a certificate. This is a very short-lived certificate. It probably lives for about an hour. And it's a typical PKI certificate, but mounted automatically into every container by a sidecar process and rotated before it expires. So if a service wants to authenticate with what it's talking to, it can use this to do so. You can think about it a bit of like a private version of Let's Encrypt, but with much shorter expiry times on the certificates and integrated with Kubernetes itself. And sort of the way we're thinking about building that is interesting because you want this system to work even in the case that there are failures in your system. So like if the identity service goes down, you don't want your entire system to go down as a result. So what we're thinking about doing there is basically putting a CA on every node. So when a node comes up, there is a bootstrap process for that node in which it can acquire an intermediate certificate, and it's sort of it's trusted at that point. You authenticate it through the AWS APIs or the APIs of your cloud provider to say, yes, this is actually a node, and it's running the operating system I expect it to be. It's running the AMI I'm expecting it to be. And those CAs issue certificates to services on that node. And they do that by a sidecar process, so the service doesn't actually have to submit it itself, submit a CSR itself and get a response. There's a sidecar process that does that and puts the certificate in kind of a known location. And this process is quite interesting to me. The Linux kernel has a lot of quite obscure features, and some of them are really useful. In this case, there's a feature of domain sockets where you can see what is actually on the other end of a domain socket. You don't have to sort of trust that this thing is the service that it says it is, you can look at the process information about that thing. And so as long as you trust the kernel, you can trust that you are talking, that the node CA is talking to the actual service it expects to be. And yeah, so the node CA receives a certificate from a central CA. This is actually a distributed thing again, and underneath all of that is Vault. And if anyone hasn't seen Vault, you should definitely check that out. It's a very cool piece of technology. We imagine that would run on dedicated infrastructure, the CA and Vault itself, because that's kind of a very security critical thing, possibly the most security critical thing. This has some parallels to some things that I believe Google does internally, and it also, I think there are some open source things, and there's been some discussions about systems like this, but I'm not aware of many that many companies are actually implementing. The reason I think a system like this is quite powerful is I think it allows you to do quite a lot of stuff. When you can confidently identify something in your network, you can sort of use that to do a lot of things. So secret management is something we think quite a lot about as a bank. So how can a service get the secrets it needs, and how can no other service get those secrets? And I think something like this is really powerful there, because if you can identify yourself very confidently to a secret store, then you can provide the secrets to that service securely. Also, message signing. Obviously, we talk to quite a lot of other parties, like, for instance, MasterCard or Faster Payments, and some of these involve signing messages. Again, only certain things should be able to sign messages, should be able to request a message to even be signed. And again, I think all of that is kind of underpinned by a strong notion of identity. Transaction authorization is the same. Not everything in our system should be able to just write into the ledger and say, please create some money. That should be something that's restricted to only a few systems, a very small number, in fact. Building is another one. If you want to build images and sign those images, you need to trust the builder, that not anything can just build images. You need to know that that is what you expect it to be. Audit logging is another one. You shouldn't just be able to write anything into an audit log and say, I am this service, it needs to be strongly authenticated that that service is who it says it is. And tunnels over the network is another one. So between our data centers and AWS, we have IPsec tunnels. And one of the modes of operation for IPsec is you can use certificates. Another great way to use this is to use those certificates from the identity system to be able to authenticate that connection and encrypt that connection. And obviously, certificates can also be used for encryption as well as authentication. This is one example of that, but I think that's something we'll be looking at a lot more in the future as well. So that was sort of a very high-level overview. I hope there's lots of questions about that. I'd be remiss if I did not say that we're hiring. If any of these kind of things interest you, please come and see us, and we'd love to work with you, I'm sure.